In our daily life, we will come into contact with various types of circuits. A direct current power supply is called a DC circuit, and AC power is called an AC circuit. Circuits exist in all kinds of devices, large and small, such as cars which have power circuits, start circuit, ignition circuit, lighting circuit, and so on. Next, let's learn about the composition of circuits. A flashlight is a common tool in people's daily life. It can form the simplest circuit. Its physical object is shown in Figure E. Figure R is a schematic diagram of a flashlight. When the switch is closed, the circuit forms a closed loop. The flashlight lights up. So what is the structure of the circuit? Which circuit do we use to analyze it? The definition of a circuit is a path of current, which is composed of actual components. Its main function is to generate, transmit, convert, and process electrical energy or electrical signals, generally regardless of the complexity of the circuit. The power supply is the device that provides power, including generators, batteries, etc. Load is the device that receives electric energy in the circuit, such as motors, lamps, intermediate link, the indispensable connection, control, and protection component between the power supply and load, such as connecting wires, switch devices, measuring devices, and various relay protection devices. As shown in the figure, the battery is the power supply in the circuit. The light bulb is the load, switches and wires are the intermediate links. These three parts are indispensable in any circuit. Circuit model. Ideal circuit elements and combinations reflect the main electromagnetic properties of actual circuit components. For the convenience of analyzing and studying circuits, we ideal components that can reflect their main electromagnetic properties to replace the actual elements. We call such an abstract circuit model. The roles and interconnections of various ideal components in the circuit. It does not represent the true geometric relationship and actual positions. In addition, in the circuit model, the wires connecting each component are also considered ideal elements, whose resistance is ignored. The actual circuit in Figure 4, when converting it to the circuit model in Figure 5. The battery in the actual circuit can be represented as the series combination of voltage source S and internal resistance Rs. The switch is represented by a switch symbol. The light bulb is represented by a resistor RL. Finally, connect them with wires. Simply, a circuit diagram composed of ideal components is called the circuit model of the physical circuit. Usually, we use circuit models for the circuit analysis and calculation. Ideal components. Ideal components with certain electromagnetic properties, which are divided into passive and active types. In the circuit model, we often use ideal components such as resistors, capacitors, inductors, and ideal current sources, ideal voltage sources, and so on. The function of a circuit is divided into two aspects. One is in the power system. Circuits can realize the transmission, distribution, and conversion of electrical energy. The other is in electronic technology. Circuits can realize the transmission, storage, and processing of electrical signals through the above learning. We know that whether the circuit is complex or not. The circuit's composition includes power supply, loads, and intermediate links. These three parts are indispensable. A practical circuit are composed of many actual circuit elements or devices. Their electromagnetic properties are more complex. In order to facilitate the analysis and research of practical circuits under certain conditions, we highlight the main electromagnetic properties and ignore its secondary factors. Use ideal components or their combinations to simulate the actual device. To model the components,